Hello, my name is Gwenael Lambrouin. I'm a R&D engineer and I'm a member of bcom, which is a private research institute located in France. And in this talk, I will tell you how we at bcom, on a proof of concept demonstrator, how we used OpenDaylight in order to automate the deployment of VPNs on heterogeneous network infrastructure. And we did this using the management plane, that is to say, the interface that can be used by network operators in order to configure their network devices by connecting directly, remotely to the devices. And on that management plane, we used the standard network configuration protocol, which is also known as NETCONF. So this presentation will be divided into 3 parts. In the first one, I will explain you the problem that we tried to solve. I will present you the key technical issues that we faced, and I will tell you why we used OpenDaylight in order to solve that problem. In the second part, I will explain you our implementation. And in the third part, we will see what is our ongoing work with OpenDaylight. And we've been using OpenDaylight for about 1 year, so I will give you some feedback about what we liked and what we liked less about OpenDaylight. So let's start with the problem to solve. So today, when you're a network operator and when you want to deploy a new service for a client, it takes a lot of time. It can take several days. And this is because there are lots of manual procedures. The client has to contact a salesperson at the operator, and then the operator has to pass the order to the technical services. And those technical services have to allocate, manage resources, plan operations to do, and then do the operations. But if we want to go faster with this process, we have to automate things. And when we can get faster service delivery, it improves the self-service experience because the client can order its service himself through a self-service portal and then get feedback a few minutes later. So we wanted to try to work on this automation problem. And we did this on a use case, which is a layer 2 virtual private network. So our starting point is a shared network infrastructure, which could be managed by the IT department of a company, or that could be managed by a network operator. And this infrastructure is heterogeneous, and it's for 2 reasons. The first one is that we have devices, here routers, from multiple vendors. And the second reason is that we have both physical and virtual routers. And we wanted to do this because we think that on the way to full network virtualization, there will be a time where you will have both physical and virtual devices. So here we can see a shared infrastructure with 3 sites, which are interconnected with an IP network. And on each site, you've got 1 or more routers. So we've got the light blue routers. And in our case, these ones were provided by Cisco. And the dark blue routers were provided by Juniper. And the routers shown with a little v are virtual routers, which are virtual machines running router firmware on commodity hardware. And on each router, we have some ports, which are resources that will be used in the VPNs. So now, on top of that infrastructure, we want the users to be able to order themselves their virtual private network service. So here we have user Orange, which asks for the creation of a VPN with 1 port on site 1 and 1 port on site 2. And we can see that the VPN has a logical switch because it's a layer 2 VPN. So when the user will plug its machines to that logical port, they will belong to the same broadcast domain, and the user will be able to manage its own IP address space, to set up its own DHCP servers, and things like that. Under the hood, we used the VPLS protocol, which is a virtual private LAN service over MPLS. That's just a technical detail. Now we can have a second user, here a user purple, which creates a logical switch spanning on site 1, site 2, and site 3. And the important thing is that its virtual network is completely isolated from the other users. So now, in order to solve this problem, we had several technical issues facing us. I will present you two of them, which are abstraction and error management. We also solved other issues, such as resource allocation and orchestration. So we want abstraction because we want the service logic. So here it is the application that will automate the creation of the VPNs. We want to have that service logic independent of the underlying hardware. And it's for two reasons. The first one is that it will simplify the development of this service application. And the second reason is that it will be possible to change the hardware, and we'll see even the management plane, without changing the service application. So one issue with abstraction is that you have to find the good level of abstraction, because if your abstraction level is too high, there are some useful features of your devices that won't be available to your end users. But on the contrary, if the abstraction level is too low, you will get features which are not useful, and it will complexify the API that you provide to the application developers. So the second key issue was error management. When you're configuring devices, sometimes the configuration fails, and it can be for several reasons. It can be because the device reported an error, for instance, because you gave him a wrong configuration, or it could also be because someone locked the device and it's not possible to configure the device. Also, sometimes the network device is not reachable. And then again, it can be for different reasons. It can be because of a physical problem, but in fact, the most common case is maybe because of an administrative problem. For instance, someone changed the user database with the credentials needed to connect to the routers. Or it could be because someone changed the configuration of the firewall between your application and your router. So when configuration fails, you have to handle this. And to do this, you have first to be able to detect that an error occurred. And then you have to have a recovery plan to recover from the error. And we'll see later two different strategies that can be used to recover from errors. So to work on this problem, we choose to use OpenDaylight, and it's for several reasons. The first one is that it's an open source network controller. So it's possible to change it and to fix it when we find issues, and that's what we did. The second reason is that it's a controller which is backed up by industry. So we can see this as a sign that some development resources will be put into the development. And also, it's a sign that some focus will be put on scalability and robustness of the controller. We choose OpenDaylight because we needed a network controller that made it possible to configure legacy network devices. It could have been with the CLI or with NetConf. And at the time we looked for such a controller, we only found OpenDaylight. So we went on with OpenDaylight. I talked to you about abstraction, and abstraction is at the heart of OpenDaylight, with the focus that OpenDaylight puts on the model-driven service abstraction layer. We found a way to model our abstractions. And also, we had heard about that OpenDaylight project, and we wanted to evaluate it. And we know by experience that in order to evaluate a product, you need a real use case. And that was an occasion to evaluate OpenDaylight for us. So now I will go into our implementation. So this is an overview of what we did. The grayed boxes are components that we developed, and the rest is what can be already found in OpenDaylight. So the first part is the self-service UI, which is a web portal that can be used by our users to create their own VPNs. The UI will pass the creation orders to the service orchestrator that will do the work that normally the technical services do at operators. And then that orchestrator will pass the operations needed to configure the devices to the generic network device driver, which is the piece of software that provides abstraction in our system. And in the following slides, I will present you the generic network device driver to begin. So that driver is a set of modules in OpenDaylight, and it exposes a model of a generic network device, which is in our case a generic router with ports. And together with this, we have some operations that will operate on the router. So for instance, in the case of the layer 2 VPN, it will be create a virtual switch on a router, or it could be add a port to an existing switch. So now I'm going to illustrate the role of each layer, and to do this, I will take an example. And so we will, and this example is adding a port to an existing VPN. So we will assume that the VPN has already created, and we will say that we're the developer of network application, and that we want to add port 3 of the light blue router, which is located on site 1, to the orange user VPN, which is VPN number 1. Just before we do this, I will make a few comments about NetConf, things that we liked. Clearly, NetConf is better than the command line interface to configure routers. The main reason is that we used the configuration data that we passed with NetConf is structured. So it's much easier to deal with that data automatically in applications. And it's especially true for when you get error responses from devices. You get a clear information that something went wrong. While when you're working with the CLI, you get a text string and you have to analyze that text string and figure out whether something went wrong or not. A problem with NetConf is that there are many useful features in the standard, but that these features are not implemented on all devices. And for instance, there's a commit feature, which makes it possible to do transactional sets of operation. And to do this well, we need to have the support from the devices, because it's very difficult to emulate in software, because when you pass a set of operations and one fails, if you want to revert all, you've got to know where it fails, and if the device is not reachable anymore, you can't roll back. So really, you need hardware support by the device to do this. So let's get back to our layers. So the generic network device driver is a set of modules that we developed inside OpenDaylight. And we used the existing NetConf driver in OpenDaylight. With this driver, you can connect to the remote devices, and you can authenticate with the devices. This driver also exposes the NetConf toolbox, that is to say the operations that are available in NetConf to help the network operators to configure their devices. So, for instance, there was the commit operation. There's also the lock operations, which makes it possible to lock a device to ensure that you're the only person that is currently configuring it. And to that NetConf driver, you pass some configuration elements, and we'll see some examples. This is an example of a configuration element. Well, it's an excerpt. It's how you can add interface gigabit Ethernet 3 to the VPN number 1 on a Cisco device. So in order to understand that kind of code, well, you need to understand the theory behind layer 2 VPNs. You need to understand how the device vendor choose to expose it, and you have to deal with XML. And it's something that it's quite complicated, and you don't want to deal with this when you're writing an application to automate the creation of a service. Then there is another example on another kind of router. It's how you add port gigabit Ethernet 003 to the Orange VPN on a Juniper device. And the key thing here is that it's not the same syntax as earlier. So if you want to deal with several devices from several vendors, you have to deal with several formatting for configuration elements. And again, it's not something we want to do, to have a device-specific code when you're writing an application to automate a service. So that's why we need an abstraction layer, and that's why we created the generic network device driver, and it's the reason of the device-independent driver. So which is a Java library developed in OpenDaylight as an OpenDaylight module. And it exposes some generic operations that can be done on our generic router. For instance, create a virtual switch on a router or add a port to a router. And then it will convert those generic operations into vendor-specific, device-specific operations. So this is an example of how you use that driver. So at first, you create a driver for a specific device. Then you open your driver, and this establishes the connection with the network device, and also it authenticates with the device. And then you can call the generic add L2 VPN port method, which will add port gigabit Ethernet 3 to the VPN, which is labeled Orange VPN, and which is VPN number 1. And when you're done, you can close the driver and disclose the connection with the device. So from a developer point of view, it's better because this code is more expressive. With less line of code, you do the same. And it's not vendor specific. But there are still some small technical details which are related to the management plane that we would like to hide to the application developers. So for instance, here you have to know what is the vendor of the device, what is the IP address of the device, what is the port to connect to the device. You have to know the credentials of the administrator on the network device. And all that stuff we would like to hide it. And so we created another abstraction layer that we called the management plane independent driver. This one is another OpenDaylight module which uses the MDSAL interface. So the interface has been written in Yang. And it abstracts the technical details of the management plane. And to do this, it relies on a management database which holds the technical details of the management plane for each device in the network. So this is an example of how you can use that layer with OpenDaylight. So it's an example of the RESTCONF protocol. So you just have to post to a given URL, and you tell it just the device ID. So here it's the virtual light blue router on site 1. You tell him the name of the VPN and the number of the VPN, and you tell it the name of the port that you want to add to the VPN. So we have something that is much simpler than our vendor-specific code. And we can see from this interface that it's possible first to change the hardware because there's nothing that is hardware-specific in this interface. And also you can change the management plane. So we could use another protocol than NetConf, or we could use another authentication scheme with the devices, for instance, public-private key inside of login password, and it's transparent to this interface. So we have seen the generic network device driver. This driver operates on one network device at a time. Now what we want to do is to automate the deployment of VPNs on a set of routers. And to do this, we need an orchestrator. And this is the purpose of the L2 VPN Service Orchestrator, which we have developed outside of OpenDaylight for historical reasons. However, it has been developed in Java using open source technology. And this service orchestrations knows a logical view of the network. The generic routers that we just saw, it knows the operations of the routers. And it exposes an API that can operate on a set of routers. So for instance, you tell him that you want to create a VPN with one port on site 1 and one port on site 2. So this orchestrator will have several things to do. The first one is that it will have to allocate resources. So in our case, it will choose on a given site on which router it allocates port and where it puts its ports. Then we'll have to plan operations. We'll have to figure out which routers need to be configured and what needs to be configured on each router. And when the planning is done, it will do the operation, and it will do this by calling the generic network device driver. Another important thing about this orchestrator is that it will have to handle errors. And I will explain you two possible recovery strategies when you encounter an error while configuring a set of devices, and when something fails at some point, the first possibility is to roll back. That is to say, to unconfigure all the devices that were already configured, and so you get your network in a clean state. But you get no service at all. And the second possible strategy is to continue on error. So you note somewhere that an error occurred, and you try to configure your service. And this makes sense if the service can operate in degraded mode with not all the features that were required. So the best strategy depends on what you want to do. In our case, we wanted to test both strategies. So what we did is that we used the rollback on error strategy when we configure a service. But when we remove a service for a client, we use the continue on error strategy. And so if something fails, we try to go on, and we try to unconfigure as many things as possible to release resources. And then we can come manually and fix what went wrong. And when this is done, we can tell the orchestrator to resume the deconstruction of the VPN. So that's for our implementation. Now there are so we have a working prototype, and we have some more work that we would like to do on it to extend it and improve it. The first part is that we would like to move our orchestration layer inside OpenDaylight. And one of the reasons is that it will make our system easier to deploy, because we will have only one software component instead of several as we have today. But in order to do this, we need persistency inside OpenDaylight, because we saw that we had some databases. The orchestration has a database of the running services and of the pending operations, and we want to have it inside OpenDaylight, and we want to be able to restart the controller without losing that information. And in our understanding, it's not possible today. We expected persistency in lithium, and in our understanding, it's not there yet. So we think that we will experiment with the persistency that is made available by the clustering mode of OpenDaylight to begin. And also, all network devices do not support NETCONF. So we'd like to extend the set of devices that we can configure. And to do this, we will develop a CLI driver. In fact, it's quite advanced, and we already have a working prototype. So, as I told you, we've been using OpenDaylight for about 1 year. We started with helium stable, and then we worked with lithium while it was developing. And so one thing that we found hard with OpenDaylight is that we found it quite difficult to start with it and to develop with it at the beginning. So it was difficult to learn and to master. And this is for several reasons. The first one is that it's a complex software with that uses lots of Java tools. You've got to understand Maven, OSGI, Karaf to develop with OpenDaylight. And when you start to go into the code, there are lots of Java libraries, so you have to understand how these libraries work in order to develop inside OpenDaylight. And at the time we started, the documentation was not always up to date, not always coherent. So it was, we found it quite difficult. Now what's encouraging is that we've seen today that this problem of documentation is quite acknowledged by the project, and that some ongoing work is going to improve this. So that's good news. Now, on the positive aspects of OpenDaylight, we found that for our use case, it was really stable and robust software. So we've done only functional tests, but anyway, we never experienced a crash or a freeze with OpenDaylight. We could let the controller running for days and weeks. We never felt the need to restart it each time we started a new demo. So that was really interesting. Also, we've experienced the bug and patch processes because we encountered some interoperability issues between the NETCONF driver in OpenDaylight and some network devices. And we investigated, we found problems, we fixed them, and then we submitted bug reports and we submitted the patches to solve these bugs. And we worked with the community in order to get these patches accepted inside Lithium and inside the master branch of OpenDaylight. And we found that the process was quite well documented, this one, and that it worked quite well. And so at the same time, we found that the OpenDaylight community was rather friendly and responsive. We had made some little mistakes in the patch submission processes, and we got some help in order to get things done. So we like the relationships with the community. So as a conclusion, what we have done here is for us another example that OpenDaylight is a generic network controller. It's not just another OpenFlow controller, so we can do things here such as managing legacy network devices. And the second point is that we have some running code at bcom, and we are ready to share this code and to work with the community on things such as improving and extending our generic device driver and working on the orchestration inside OpenDaylight. So if you are interested in this, well, you can contact me during the conference, or you can contact me at my email address, gwenael.lambrouin@b-com. And if you're interested in those slides, they're available on SlideShare normally. So this is the end of my presentation. Thank you for your attention. And if you have any question, I'll try to answer them now. Yep. You guys. It was at the edge of the network in our case. Yes, we have not worked with CPEs.
Are you looking at other use cases with virtual CPE and extending the VPN x86 type of devices at the premise? Is that something you're
Actually, we've also worked on layer 3 VPNs, but still at the edge of the network, and we've not worked with CPEs yet.
Is that something you're looking at?
Maybe in another project we could do this, yes.
And one more question. A lot of operators, service providers, are extending VPNs over layer 2 and 3 to connect to cloud services.
Yes.
Private cloud services, so the operators can start offering VPN connection to a cloud gateway.
Mm-hmm.
That would be a very interesting use case to see that moving workloads from Amazon to the private cloud. And is that something, I mean, with OpenDaylight, it would be interesting to see that schools are looking at that kind of use case as well.
Yes, that could be used. In fact, last year we worked on a prototype with layer 3 VPNs where we automated the creation of the VPN in the network, and then we had a tenant in a data center, and we had an orchestration layer that could make the relationships between the VPN and the tenant in the network. Any other question? Okay, so thank you, and good evening.